All right, welcome. Let's start talking about preparing data in Tableau. So our goal today is to explain how to prepare and clean healthcare data within Tableau Public. If you've got Tableau Prep, stop bragging. We get it. It's what would be easier, but that's not what we're dealing with, okay? All right, let's look at data prep in Tableau Public. Common healthcare data sources. Often if you're brand new to healthcare, you might not know where the data is created, who has it, what kind of different data might we bump into. So I've just got a quick walk through to help you start thinking about how data is created and what it's created about in the healthcare setting, because there are many different times and places where this can happen. A patient can be using wearables or applications on their phone, and those companies all keep and track their data in the cloud. They also may have a visit to the hospital, an online visit. They may end up in the ambulatory setting. All of those are going to create a record in the health system that's going to capture what has happened for them throughout their stay, including, but not limited to, labs, imaging, pharmacy, and I have a typo, pharmacy again. Oh well. Then they have to be billed. They have to pay. That's how this works. So records have to go to the insurance company or the government in order to get compensated for the work that the healthcare provider gave to that patient. So each one of these is creating data. There is tons of data captured and kept on patients, often in different places, and so it might have a little bit of a different flavor based on where you're at, but the general idea is that they're capturing any time that they interact with a patient and have to do something for a patient. So just as a connection to what we talked about last time, that is the left-hand side of this visualization, where data will end up in a database or online in a server or come out of a database into a file for you to use in the Tableau universe in order to build and present your information.
This is my data quality framework. This is a step-by-step process to walk through whenever you get to a dataset for the first time in order to make sure that you've counted out all of the obvious things that could be wrong with the data. You've handled and addressed any things that could cause major errors in your conclusions. So it starts with some initial profiling. That is, start a data dictionary. If you're not familiar with data and analytics, you might not know what I mean by a data dictionary. It is very simply a list of columns and what they are. What's the description of it? What is the definition? What kind of data is it? A lot of times this can be something that the institution has already produced and is sitting somewhere in the data governance structure. But if it doesn't, start one. Start your own. Even if the one in the data governance structure is available, but it isn't written in a language that you can understand, get your own started, because whether it's at the beginning of the project or the end, it is very likely that at some point you're going to need a way to communicate what is in this data set that you're using and what is your understanding of each column that you're using. So this is not something that happens in Tableau. In fact, Tableau really sucks at this. This is something to go back to the basics, go to Excel, and start yourself a list. After you've got a data dictionary, After you've got a data dictionary started, your task is to find a unique identifier. Figure out what it is in your dataset that actually makes each record individually unique so that there are no duplicates. In our dataset, because I created it, I know a little bit about this. The thing that makes it unique is the encounter ID. This is actually a pretty common concept in healthcare data, is that the encounter ID or some sort of ID represents the record level. And so here, one record represents one encounter or time that we took care of the patient. Now, an encounter can be many days. It can be from the time we admitted them to many months later when they get out of the hospital. But the encounter identifier represents that entire encounter. And so the way that I can verify that this is for sure unique is to go ahead and do a count distinct of this versus a count of it. So I'm going to start by, since I don't have too many measures, the automatic action that Tableau takes when I hit measure values is kind of what I want. I'm not going to use the measures that it picks, but I'm going to create my own. So the first one is going to be a distinct count of encounters. So the distinct count function is you get to by using count D, and then you put in the field or the column that you want to have a distinct count of. So here I want that encounter ID. I'm going to get rid of the other noise here, and if I get rid of this last one, it's going to bump me out of this sort of setup. So I'm going to keep here for a second. The next thing I want to do is see how many records there are overall. So I've got a distinct count of the encounters, and if that matches the total count of the records, that means that there's a unique identifier on each one of those records. Now that is the case here, and we can see it really clearly. So I'm going to go ahead and rename this sheet to be something meaningful, like unique. Next, I'm going to start a column to find where is the missingness in my data. For this first simple missingness, to see how much is missing by each column, I'm going to go ahead and go to the patient encounter pivot. Now I want to figure out how much missingness I have in my data, and I'm going to do this in the simplest way possible first. I'm going to head to our patient encounters pivot, which we've already made, so that I can see by each field name what is the total count of the records, and then how much is missing. In order to figure out how much is missing, I need to create a calculated field. I'm going to come here to analysis, create calculated field, and call it missing, and do a if statement that says, if the pivot field value is null, and that function is null, is used like this, where we say is null, open parentheses, and the field we want to check for nulls. So I'm saying if that field is null, then give me a 1, else give me a 0. I'll do an end there, and I'm going to do a sum of this if statement. So I'm going to sum this up. Basically, I'll get a sum of 1 every time that pivot field value is null. And now I've got a number missing. I'm going to double click that to bring it into my visual, because it's going to do this great step, which I really like, where it puts the measure values as the text that is being shared, and it brings a new dialog box or box down here for the different measures I want to use, while putting the measure names up here in the columns. It's an automatic action I've come to rely on because it's very handy for getting started. This way I've got a table that has a meaningful description of what the measure is that's above each of these columns. So we have 9,326 records for the field cost. 34 of them have missingness. And so I want to see what this represents as a percent of the data set. So I'm going to make one more calculation, which will be percent missing. And here I'm going to take that missing value that we created and divide it by the overall count of the records in the data set. So I'm actually just going to drop and drag this count item over here. And you'll see how it works. It's using the count function, but instead of doing a count on an individual field, it's doing a count on this data set overall. And so now I've got a percent missing to add in as a field. It's showing zeros because I need to format it to be like a percentage. And when I do so, I get a percentage with 2 decimal places, and we can see where the greatest amount of missingness in our data is. And that is here on the encounter date, where we have 2.6% of our data missing. Now, the general rule of thumb that I've always heard is anything under 3% missingness is reasonable and is very unlikely to affect in a meaningful way the outcomes that you create from an analysis. That is not a perfect fit for every situation, so don't rely on it solely. The other important thing to know is anytime data is missing in healthcare, it is worthwhile to track down the reason why. So even though it is below the threshold, we're not overly concerned. The next action to take is to go work with the data set owner, work with somebody in the practice where this data is created, and try to figure out, for a record where there is no data on one of these columns, why might that have happened? So even if you can't fix it, you will have a reason and an understanding of the data and its creation. That will do wonders in making proponents of yours know that you are an informed user of the information. So it's the best step to take, but right now we are going to say everything's under 3%. We are not overly concerned. I'm going to add a few other measures onto this data set in order to continue to profile in a generic way. Now that we've got the basic missingness outlined, I'm going to name this worksheet like for that. and I'm going to create a new worksheet where we're going to look at a different pattern in the missingness. So this is why we've created the patient encounter double pivot. We want to see the interaction of columns when there's missingness in more than one column for the same encounter. If you remember, we pivoted the data twice and we reconnected it on the same encounter, but only where the encounter pivot field name is not the same, not the encounter pivot field name, but the pivot field name is not the same. So when I bring out pivot field name from the first data set that was pivoted and pivot field name from the second, what we have is the intersection of each of those so that we can see how many times is it that there is no information for cost and no information for department, or cost and encounter date, or cost and length of stay. This will help find any patterns that might exist in the data around why and when information is missing. So we need to create a new measure here. First, we need calculation for that missingness. In order to make this a little bit simpler process, we're going to do it in steps. And so missing is going to be done in much the same way it was before. We're going to do a sum of if is null of the pivot field values column and is null of the pivot field values pivot 1, which is the secondary data set here. When both of those conditions are true, then give me a 1, else I want it 0. We will end that and close the sum function. We have an error, so let's figure out what's going on. It says expected a then to match the if. So I said, if this is true and this is true, oh, this is what it is. We've got an extra parentheses. So now we've got a working missing, number missing in each of these. I can put it up here to find out where is that missingness. We've got 64 missing where there is missingness for the department and the encounter date. But we only have 16, 17 missing for cost and some of these encounter dates. So let's go ahead and make this a little bit more formal. Let's get to the percentage of time that this happens. And let's also go ahead and color it like a heat map so there's some good signal here. So I want to start by doing a new measure that is the percent of missingness. So we're going to have to create a calculated field, and we will use the missing field that we just created and divide it by the count in the data set here, which will be the count of this second data set because it's the longest and biggest one of these. But both should give us the same value, to be honest. So I'm going to do percent missing here. I'm going to say OK and put it in instead. Oh, it wanted to keep both. I don't want that, and I want to get this formatted so it's working properly. I'm going to turn it into a percentage, and I'm going to keep those two decimal places. Now we've got the percentage that this represents, and none of them are a very substantial percentage at all. So this further leads us to believe that there's not a major issue in missingness. I'll just show you one other step that's kind of nice in this, that we can turn it into a heat map in order to create a little better signal. So visually, you can quickly navigate to what's important here. I accidentally sorted it in a strange way, so I'm going to get rid of that. I don't like these colors, so I'm going to change that color pattern a little bit in order to get it like I typically have it. So the way that we do that is go to the marks card and the color button, go to edit colors, and I like to change this into a diverging so that there's two different color elements. I always start from white and then I go into a color that represents signal. And so here I'm going to choose orange. I like to do a stepped color so that there's a really good contrast between each level. And so here it does a really nice job of saying there's some signal in all of the column interactions, but the most is between department and encounter date. So this is the type of thing we wanted to know. Now, this is some indication that there's not a lot of missingness in our data, and there's not a lot of pattern to that missingness. However, there is some pattern in that many of the encounters that don't have a date a date in there also don't have a department. So this is something that we might consider for filtering out. Because we have encounters that we don't know the department that it went to and they don't know the date of this encounter, first of all, let's go see if we can find out the answer. Let's search the chart. Let's talk to the people that created the data, find out why this might be happening. And if we can't, this may be candidates for getting rid of this data because we don't have very much information in it to be used later on. We'll come back to that in another step. But right now we have missingness and we have a missingness correlation matrix. And so we've got a really good head start on our profiling. In fact, this really covers the initial profiling, which is start with the data dictionary, find a unique identifier, clean up some columns, which I can show an example of, then start quantifying missingness and evaluate any missingness patterns. So we're already down through number 2. One thing I glossed over was the cleanup of columns. I just want you to see how we might adjust the columns here in this data set. The 2 major operations that I'm doing to clean up columns is renaming columns to be more meaningful. An example of how I might do that in a data set like this, while this does represent encounters, encounters tend to be over multiple days in a hospital, and so the encounter date is not a very descriptive title because almost certainly this date represents the admission date or the discharge date, and I'd like to know which one. My usual pattern would be to go back to the data owner, go back to the data source, and find out what date this actually represents, and to rename it by right-clicking on this pill, choosing rename, and then making this the discharge date instead of the encounter date. So now it's a little more descriptive. Another action that I am taking usually in order to clean up the data is changing fields from an ID or from a dimension to a measure. So here, patient ID is as a dimension, which is reasonable. That's actually what we would want. But it is common that IDs, because they are numeric sometimes, come in as a measure so that Tableau thinks you might want to summarize or take the average of, take the minimum of this field. That would really rarely be the case. So you would want it to actually be a dimension. So the way that you do that is to right-click on it and choose Convert to Dimension. Those are the 2 primary things we do when cleaning up the data set. So we have now done the initial profiling and profiled the missingness. Let's check for outliers using histograms and ranges. The way that I go about this is creating new tabs for each of our columns. So we're going to head back to that basic data set of patient encounter, and I'm going to grab the department column, and then I'm going to see a count of the records in the data, and I'm going to turn that into a visual so I just get some sense of proportion. So now I can see that there's a pretty even distribution of the records across these different departments and some missingness which we did know about. This is a chance for you to use your institutional context to say, yes, this seems reasonable. There is some similar volumes of patients that go to each of these departments. But if your institutional context tells you that there's a lot more volume in orthopedics than there is in pediatrics, then you would know from this that something is off in the data collection or how you're using the data. So that's why we do this sort of activity. There's no signal here that there's an issue, so we're going to keep moving. Next, let's head over to a numerical column. Let's take cost as an example. I'm going to pull it out here, and then I'm going to go to Show Me up in the upper right-hand corner and choose the histogram. This is a really common thing for me to do in order to profile the numerical values that are in my data set. This is going to build something like a distribution, a histogram of how many times in my data set do I have a value in the cost field that is in this bin that goes from presumably 0 up to 413, and the second bin goes from 413 to 826. You can adjust the bins by coming over to the bin field that was automatically created when I chose histogram by saying edit, and then you can change that bin size. I can make it as small as 1 so that we see a new bar for every $1 increment in the change in cost, but that would be unlikely to be helpful to us. What we see here is a pretty even distribution of low cost to high cost encounters. That may be reasonable in a lot of healthcare institutions. This would be a signal that we have data that is collected in an odd way, because usually we have a lot of low cost encounters and a small number of very, very high cost encounters that skew our data. But that's not what I'm seeing here. Also, I know this is fake data I created. So there's going to be some patterns that aren't very realistic, and that is just the truth of it. So I'm going to name this one cost. Now you've seen an example of profiling the range and shape of the data for a numerical example and a dimension example like department. Let's do one last one and look at a date type range. We have only one date in this, and I've changed it, of course, to be called the discharge date. So I'm going to bring that out into our visualization. The default for date is always this year, and I am going to go ahead and switch that. I want it to be month, but I'm not going to choose the first month option. That first month option, as you can see in the light gray, is going to give me just the month name. But if I come down here to the second month option, I get the month and year. After that, I need some sense of the volume of records that have each of these dates. So I'm going to pull that in here to the rows. And now I've got a nice line graph that shows me what is the volume of records for each one of these months in my data set. I also see that the range of dates in my data set are from February 2023, or probably rather, January, through December of 2024. So we've got 2 years of data here. It looks like there is good full data in each one of the months. None of the months seems extremely low, like sometimes the first month cannot have full data in it, or the last month. That doesn't seem to be the case here. That is what I'm looking for, is to see, do I have full data and what is the date range? Now we have a profile generally of the different fields in our data set. If this were a bigger data set or a more serious project, I would take on this task of profiling each one of the columns individually to find out, what does the data look like? What are some possible issues that might exist there? So that is checking for outliers, looking at histograms and ranges. The next thing is to consider fixing things. So there's a couple of ideas on how to fix things. Let's show you two different ideas. One would be to filter out the data. Now, we saw before in this missingness correlation that we have quite a few encounters that have no encounter date plus no department date. Also, no encounter and no cost, no encounter and length of stay. No encounter date. So I'm going to go ahead and make the determination that if I have an encounter in here with no encounter date, that it's not good data, or I don't want to capture and start counting it. So I'm going to go ahead and filter that out. Now there's multiple different ways that I can do that. Number one is I can do it on each individual worksheet by itself, in which I can bring the discharge date column up here to filters. I can go to just next here, because I'm not going to use any specific one of those. What I'm looking for is on the far right here where it says special, and I choose non-null dates. So I only want to include non-null dates. So I've now just filtered only this visualization. Now that's really not what I was trying to do. So there's a couple other options that you have. Number one, you can click on that filter and choose what it applies to. So you can have it apply to all using the related data source, all using this data source, or to select worksheets. I would recommend using one of the top two, or a third option, which I'm about to show you. I'm going to take the filter off of here. Remember that we have 9326 here as the value. We're going to come back and do a data source filter. So we're going to come back to the data source of patient encounters, and you'll see in the upper right-hand corner a place where we have the option to add filters. So I'm going to add one here. I'm going to put it on the discharge date. I am going to go ahead and do that. Actually, range of dates is where I start, not because I want to do range of dates, but that is where I get this option for special, where I can say non-null dates. So now this filter will be applied at the data source level before you ever start building anything. This enables you to use this data going forward without looking at having to recreate that filter every time, or apply that filter and have it in all of your information. All right, so now we've got one version of cleaning up our data done. We've got it filtered out so that those encounters that don't have a date, we're not even going to look at in our work. The other thing that we might want to look at is, how do we handle cost? So now that we've done this, we still have some fields that don't have cost in them. So there are a couple of approaches that can help you still keep all those records and not skew your results. One of those is to go ahead and ignore it, because if you were to build out some sort of measure on cost, you will get only data where there is actually data. You can even do that more explicitly by, in your visualization, coming up here to where cost, much like the date, is non-null. So that's one option that you have, is to do it at the individual visualization level. But another opportunity that you have is to go ahead and impute the cost. So that is to fill in the cost wherever it is 0. We would do that by using a calculated field. And so what we're going to do is say, if is null the cost field, then we are going to take the average. Then we're going to take something called a fixed. We're going to do a fixed level of detail calc where we do fixed to the data set, essentially. If we don't put in a specific column, it's just fixed to the data set. What is the average of the cost column? And I close it in this way. Level of detail calculations are a little more advanced topics, so I won't go deep into them, but I want you to see this opportunity as to how you can go ahead and take the average of the entire data set and input it as one of the inputs in another equation. So we're saying if the cost value is not in the data set, then take the average of the entire data set in that cost column and put it in there. Else, give us just the cost column, because if it's not null, then we have a piece of data in there. I'm going to hit end on this. Now we've got a calculation that's working that we can call imputed cost. All right, now we can bring imputed cost over here and see that we have a really similar result. That was kind of a quick and dirty way, but let's go ahead and look at a new visualization. And let's look at two different things. Let's look at the average of cost. I'm going to turn that into text here. And then I'm going to look at the average of the imputed cost. So I'm going to turn this into an average. Whoops, wrong choice. Did not mean to do that. Measure, average. Look at that. We have basically the same value here for average cost and average imputed cost. I bet you if we took this down to the very detailed level where we had it as a number custom with 2 decimal places, we would get a different answer. Maybe we'll need 3 decimal places just to show you that these are actually going to be different. They won't be very different because for the most part we don't have much missingness, but no, they're not very different. Okay, so let's go ahead. I just want you to see in the data source what this looks like. So in the data source, in patient encounters, let's look through the cost column to see if we can find any nulls. Here we go. We've got a data piece here on row 21, encounter 21. There is no cost. In fact, all of the encounters here in my view currently have no cost. However, if you look in our data set, because I've made this imputed cost, where is the imputed cost? Hold on. Patient encounter, imputed cost. Yeah, I thought I would have seen it here. Usually I see it here in one of these. You actually see it in the data set. So let's go ahead and try to see what this looks like for different encounters in our data set. We have here an example. Let's go ahead and put the measure names here and the measure values for the data. Okay, so we have the average cost here for each individual encounter, which would just be the total cost that it is. Let's go ahead and make this simpler. Now that I've got imputed cost, let's go ahead and look at cost and imputed cost here in our data by the individual encounter ID. What I'd like to see is some encounters that don't have a cost in there, but we can see their imputed cost. So let's go ahead and get that in there. I'm going to bring this to the text there so we can see that. All right, we've got some encounters here that don't have any actual cost in there. And I am going to go ahead and take the imputed cost and input it. All right, so we can see 4 encounters where there already was a cost. The cost that was there is what is entered. However, 4 encounters that did not have a cost, it gets the average cost of the overall data set. And so this is what it does to your data, is it tries to fill in that column. That is the concept of imputation. Now, there are other types of imputation, like taking the last value, taking the value next to it, taking the minimum value, taking the maximum value, all sorts of rule-based ways to fill in these columns. It becomes really important if you're doing something like data science. Whenever you're doing typical analysis of a data set in which you're looking at trends in populations, I actually feel that imputation is a hindrance to getting at good information, because you'll be representing that, for example, this encounter number 21, had $10,000 worth of cost, which did not actually happen. So it's a more important concept when you move on to something like data science and predictive algorithms, but it's not as important in representing the data for analysis. So that is the concept of fixing things that you see wrong. Those are the 2 kind of options you have, which is to remove data that isn't going to be helpful to you, and then also, if you need to, impute or put in a filler or a holding value into those blank fields. Next, let's talk about the concept of building a monitoring framework. Building a monitoring framework, I like to put out there as a great last step. I don't have any great visuals to show you. The concept is this. I want to make sure that my data stays clean. If I'm going to continue to use this to make decisions, I want to make sure I have a regular cadence of coming back and evaluating, is there any new pattern in missingness? Do I have any more missingness than I used to? And wherever possible, can I actually improve the data quality by presenting it back to the people who are creating that data? So this is the idea that after you get done with the cleaning process, consider what can be used in order to be able to continue to monitor how clean your data is. So that can be creating a dashboard that you come to every month and share with an end user that helps create the data, or it might be something like regular checks with end users on an annual basis. It's not always needed, so that's an important question to ask. The why it matters, or what matters, the things that you're typically trying to monitor is how much missingness do I have in this data, and what is the average of my numerical fields? Is that shifting or changing? Do we feel that that's true, or that there's a possibility that error is creating the shifting or changing that is happening there? So that is the concept of data profiling in Tableau Public. You now have the ability to enter a data set for the first time and make sure that it is set up for you to start using, that it's clean, that it can be trusted, and you've got a better understanding of the data that you're using. Way to go.